Good evening, everyone. So, welcome to today's live session. So, today we'll be continuing optics topic, which is very high scoring topic. In physics, so you'll be learning mechanics, thermodynamics, electromagnetics, but sometimes students generally not focus much on optics. We will see that what is the expected number of questions. If you see in ray optics in the last few years, like 2014 to 15, if you see on an average, we're getting at least 3 questions. So 3 questions, and we are saying optics, and today we are going to cover not only just ray optics but as well as wave optics. So ray plus wave, so you are going to have at least here 3 questions, here one, at least total 4 questions today. So 4 questions, 16 marks. So I can guess that easily today in 1 hour we'll be trying to revise the 16 marks will be easily guaranteed. And in this ray optics, should you prepare all the topic? And yes, I was telling earlier that students, they will not be focusing much on ray optics because it is a vast topic when compared to bigger. It's one of the biggest chapter in the second year also. But is it compulsory to prepare each and every topic? Again, what are the things where you have to focus? You see on the mirrors and the lenses. These are the topics where the questions will be generally asked. Here you can expect one question. Here definitely one question will come, and here one question is expected. And remaining topics, that is either the basics refraction part, TAR part, prism, and optical instrument. These are the 4 other topics where you can get the questions from. So once you know what you have to study, why you have to study, is you are going to get 3 questions, and what you have to study, these are the topics. Let us see what the things which are required. Ray optics is all about what? So it is just about image formation. So whenever there is an object, how the image is formed. Again, very few formulas will be very important, and most of the things can be understood or revised from the diagrams. The first thing, it starts with the mirror, and if you take spherical mirror, what are the formulas involved for the spherical mirror? So for the spherical mirror, we can say that if there is a concave or convex mirror, so first it is going to have center, this is the focus, and if you have object distance where the image will be formed, so for this 1 by v plus 1 by u is equal to 1 by f, and what is f is equal to r by 2. So this is one formula, and m, magnification factor, is minus v by u. So this is a basic formula we must remember. For mirrors, this is like more or less, if you know and how to draw a diagram, it is done. Next, regarding refraction, that is where the major applications are. Refraction, it starts with the loss of refraction, and the major thing is Snell's law, mu1 sin I is equal to mu2 sin r. And then applications like if object is in rarer medium, if observer is in denser medium, and if you are observing, so what is going to happen? If this is object height, it will appear, so apparent height will be mu times the real height, and if you reverse it, then apparent depth will be, so d times mu. These applications we have to remember. After that, we have 2 formulas regarding the normal shift. What is the normal shift? Is, again, if you are observing, if this is the length, it's a slab, if you take it having the refractive index, and if you are seeing from this side, if object is here, then it is going to appear shifted towards the slab along the normal. What is the normal shift formula will be coming out? The normal shift is equal to t into 1 minus 1 by mu it is. And then after learning about the slabs, parallel, and then we have the special case of TAR. So what is TAR? So whenever there are 2 conditions, whenever light is trying to enter from denser medium, and if angle of incidence is greater than critical angle, then it undergoes total internal reflection. What is this critical angle? We'll find it by using sin theta c is equal to mu rarer by mu denser. And what are the applications? It will be combined with prism. And for prism, again, just I'm trying to give you quick overview of the things. Prism, again, few important things like what is the general deviation is. General deviation is I plus E minus A, where A is equal to R1 plus R2, and a relation for minimum deviation, it occurs when I is equal to E, angle of incidence is equal to angle of emergence. And then comes one important formula for refractive index, mu is equal to sine of A plus minimum deviation by 2 by sine A by 2. So this is for regular prism. For thin prism, what are the things will be coming out is, so again for thin prism, what is a, if this is small angle, deviation is equal to mu minus 1 into A. Okay, and next if you are looking at, so lenses. So for lenses, very important topic. Few things I'll fast forward it. So first, how to find focal length? 1 by f is equal to mu minus 1 when it is in air. 1 by r1 minus 1 by r2 is a formula. And this is the lens maker's formula to find the focal length. If it is in the medium, then we should take the relative refractive index here. And how to find image, 1 by v minus 1 by u is equal to 1 by f, and then m magnification factor is equal to v by u. And whenever using all these formulas, I'll put an asterisk mark, that is conditions apply. What are the conditions are? You have to use sign convention. So these are the lenses, and then comes combination of lenses, cutting of lenses. This is where the questions have been asked. Combination, when the lenses are in contact, if this is one lens, this is another lens, if they're in contact, if you want to find effective focal length, 1 by f effective is equal to 1 by f1 plus 1 by f2, and use the signs. Focal length for convex lens is positive, focal length for concave lens is negative. Always use the signs. Then equivalent power will be p1 plus p2. If there are more are there, you can keep on adding. Okay, and after this, so lenses, where do we use them? In instruments, we have compound microscope and telescope. Those are the things, applications, we can write it. So let us see, again this is a basic overview, and formulas for instruments also we'll see while doing the questions. Okay, so let us start what the questions are for ray optics. Again, easy scoring. It's not like too much applications will be there, direct. So we have a light rays falling on the glass surface and its refractive index is given. So we have a glass surface whose refractive index is given and light is falling. That's it. And angle is given as 60 degrees. Whenever we are measuring the angle, it should be measured with normal incidence. And refractive index is given. Now they're asking what is the angle between. So here some part will be reflected, some part will be refracted. They're asking this angle between reflected ray and refracted ray. So just two laws done. What are the two laws are here? What is happening? Reflection, so angle should be 60 degrees, and here what is happening? Refraction. Okay, so if you apply this, then what will be coming out? Now we have this angle. Okay, once again, we should not take this as 90 degrees. We don't know what is the angle, that's what we are here to find. So just we correct it. Now how to find R? So Snell's law. What is the Snell's law? Once again, just now we have seen. So mu 1 sine I, that is 60, is equal to mu 2, that is root 3 into sine R. I think you got the answer. So root 3 by 2 is equal to root 3 into sine R. So root 3 got cancelled. Sine R is equal to 1 by 2. What is the angle it is coming? So R is equal to 30. Again, so if you know this is 30, if you know this is 60, yes, then we could say confirm that it is 90 degrees. So again, so the answer for this is 90 degrees. Very simple. And these are the previous year's questions that we are solving. So you can see that the questions are not at all complicated. That's the reason why you can score 180 out of 180 and overall 720 out of 720. So what is the thing we are having here? So again, it's ray optics all about image formation. Image formation needs regular refraction or refraction. Yes, it is a true statement. And statement 2, they're asking the variety of color of objects we see around is due to consistent colors of the incident light on them. It is due to the colors that we are seeing is, what is the reason behind the colors? So the variety of colors of object we see around is due to the constant colors of the light incident on them. Yes, if the light has that particular color, then it would be reflected, then we can see. So here first is correct, second is correct, so both are correct. So both statements are true. Again, basic common sense questions we are seeing here. Next, we have again regarding the mirror. Again, mirrors, lenses, compulsory. So an object is placed at a distance of concave mirror. Diagram is compulsory as well. Ray optics. We have object is placed at a distance of 40 centimeters here, and focal length is given as 15 centimeters. And now we are saying what? Okay, object is displaced. Initially this was 40 centimeters. Now object is displaced towards the mirror. Okay, it is gone this side 20 centimeters. Then they are asking what is the displacement of the image will be. Again, it's a straightforward question, but little bit of solving is required. So if object moves, image also moves. So first for this, let us say this O1 for the first object, first image. When it comes here, let us say it is O2 for second object, second image. So first, for the first time reflection, let us apply the mirror formula. So when you are applying the mirror formula, what will be coming out? So we will be seeing that, so 1 by, this is a mirror, 1 by V plus 1 by U is equal to 1 by F, 1 by V plus U, it is minus 20, and F is 1 by 15. So first image 1 by V1 plus 1 by, if you just solve it, what it is coming out to be? 1 by 15 plus 1 by 20. So what is V1? So again, so if we take, this is 1 by V1, still we are doing 35 by, this is 300. So 7, and this is 60. So we got V1 is equal to 60 by 7. And next, so we have to go for second one. So for the second reflection, so what, 1 by, again 1 by V plus, since it is gone 20 now, this becomes directly, I am writing 1 by V2 is equal to 1 by 15. The focal length, we should take it as positive because it is a, okay, 1 second, yes, one mistake I should say, they have given concave. So concave we should take. So one thing we have to take, one correction. So what will happen here? Here focal length for concave minus will be coming. Just one thing we have to change it here. This is just where we have to be careful. The sign convention, and you have to be careful, concave, convex. Just if you are not in a hurry, the things will be coming. So minus 1 by 15. If we take 5 common, then minus 1 by 3 plus 1 by 4. So what is the answer will be coming out? 1 by V1, then minus 4 plus 3, 1 by 5, then it will be minus 1 by 12. So what is V1 is coming out to be? Minus 60 centimeters. So V1 is at minus 60. Okay, so done. Yes. Is it fine? Calculation, once you have to check it, it doesn't feel right because U is far, it should be coming less. 1 by 5, 1 by 3, 1 by 4, this is plus, minus 4, yes, it's fine. Okay. Okay, now let us go for this one. So what it will be coming out here? Minus, so 1 by V2 is equal to, okay, so that's what here. Let us say this is second reflection, this is the first reflection here. So now the distance is 40 here. What will be coming out? Minus 1 by 15 plus 1 by 40. So again solving 1 by V2, 1 by 5 take it out, minus 1 by 3 plus 1 by 8. So what is, this will be coming out V2, so 5, or if you just solve it further, again just take some time to solve the things, and minus 8 plus 3 minus 5 by 24. So 5 got cancelled. The second image is at minus 24 centimeters it is. How much distance? First, so first it is at minus 60. So what is the gap? It is 36 centimeters. So 36 centimeters where it is? So initially here, then finally here, it is going, when we move towards, it will move away. So it will should be coming to be away from the mirror, should be coming out. Okay, so first image is this one, second image is 60. So from 24 it is going to 60. From 24 when you go to 60, it is traveling 36 meters, 36 centimeters will be coming out. Okay, so now what you are having, we have this relative permittivity and relative permeability are given. Generally what this is useful for, and how optics is related to this is, you can find speed. Speed is equal to, like normally if you are talking with her, they are asking to find what? Refractive index. How to find refractive index? Normally C by V, right? And so what is C itself is 1 by mu naught epsilon naught. What is V is equal to 1 by mu into epsilon. This is what is the formulas individually. So now they are asking to find, so we have relative permittivity and permeability as are given. You can see that, so that is 2 and 1.5 represents, this is epsilon r and this is mu r. So let us substitute in the formula and look. So let us divide them both first of all. So since, okay, let us call refractive index with another symbol here. Let us call it as n, because mu and epsilon are occupied. So n is equal to c by v, and what will happen? It becomes under root of, so mu epsilon by mu naught epsilon naught. So this will be under root of mu r epsilon r. So directly we can put the values now. It is what? 2 into 1.5. What is refractive index is coming out to be? Root 3. So again, direct formula based question it is. Okay. So we have, so direct formula here, okay, we can take it, that is n is equal to under root of mu r into epsilon r it is. Okay. So when the relative permittivity and relative permeability are given, directly we can take it. Now coming to what is the things, critical angle question it is, TAR. Again, total 4 topics were important. One of them is TAR here. So how to find critical angle? Basic formula is what? Sin theta c is equal to mu rarer by mu denser it is. So light travels distance x in t1 time. So light, it is traveling. So they are trying to give the distance. So we can say v in air, okay, v speed is equal to distance by time. Okay, fine. Let us capture whatever the information given. Next, it is traveling 10x in time t2. So speed is equal to what? 10x by t2. Fine. So we have both speeds. Then what is the critical angle? If you know c by v, can you find refractive index or not? C by v. So x by t1 by 10x by t2, xx, if it cancel, so t2 goes to numerator, t2 10 t1. We got refractive index. So first medium is air, 1 by mu. So 1 by mu will be what? 10 t1 by t2. Done. So we want theta c. What should write? Sin inverse of 10 t1 by t2 it is. Again, so little bit of kinematics and basic concepts we got it. So answer should be what? 10 t1 by t2. That is option C it is. Okay. So again, ray optics is easy chapter, formulas and understanding of concept is necessary. So do multiple revisions. It will be very much helpful. Next, so lenses, again repeated things. Within lens also they can ask different things. Now they are saying 2 lenses of same focal length, but one is convex and other one is concave. Okay, we have this focal length is positive, this focal length is negative. Okay, what they are doing? Okay, they are saying that they are in contact. Okay, let's bring them into contact. So if you put them in contact, so again, just I'll erase it and I'll show it here. When they are in contact, I think yes, they will be asking equivalent focal length. This is plus f. Again, just now also I told you the formulas. What is effective focal length? 1 by effective focal length is equal to 1 by f1 plus 1 by f2. First one is plus 1 by f minus 1 by f. So I think you got the answer. 1 by effective focal length is 0. That means effective focal length is infinity or undefined. Infinity is there? Yes. So answer is infinity. Okay, direct question on combination of lenses, direct formula based. Next, again, so we have lens based question. It is made up of 3 different medium, and a point object is placed at a distance, okay, some distance apart. How many images will be formed? So see, for this medium there is one refractive index, for this medium another refractive index, and last one another refractive index. When you have 3 different types of medium, so we'll be having 3 different focal length. If there are 3 different focal length, then there will be 3 points where it will be focused and 3 images will be formed. So again, very simple. Here is number of media is equivalent to number of images it is. How many images will be formed is equal to that many. So 3 are there, so 3 will be. And this is also asked, previously also they asked related to this question. In JEE also they asked this question. Very simple, direct, straightforward question. So lenses, we are seeing the questions. I hope you got the confidence required. Lengths, easy questions only are there here. So next, again finding equivalent focal length, only one formula, combination of lenses, and okay, we have to find, they did not give any focal length. So we are having no choice but to calculate ourselves. Okay, this is first lens, this is second lens, and this is third lens. So three lenses are there. If three lenses are there, we have to find three focal lengths. So again, how to find, since radius are same, so we can treat first and third are same only. We can treat first and third are same. So our work reduce little bit. So first focal length if you find, second focal length is fine, done. So let us find first one. First lens, lens 1 is a plano concave lens it is. So concave 1 by f1 is equal to mu. Mu is given as what? It is 1.6 minus 1 into first radius is infinity minus second radius is positive, and radius of curvature is 1 by 20 centimeters it is given. 1 by f1 is coming out to be 0.6 into minus 1 by 20. Let us keep it as it is. Next, let us go for lens 2. If you go for lens 2, so we have biconvex lens it is, then 1 by f2 is equal to, its refractive index is what? 1.5 minus 1. Again, we should treat them separately. When you treat it separately, it is like in the air. This is also in the air. This is also in the air. So three lenses, three focal lengths. So first and third are same. So we are leaving that. So what is the thing we have to do? 1 by r1, that is 20, and minus of minus become plus 1 by 20. So 1 by f2 is coming to be what? 0.5, 1 by 2. This is 1 by 10. So it is again 1 by 20. So we got two focal length. We want to find effective focal length. So we are almost at the end of solving. 1 by f effective is equal to, so 1 by f1 plus 1 by f2 plus 1 by f3. But f1 and f2 both are same. I'll write it as 2, 1 by f1, that is 0.6 by 20. This is minus plus 1 by 20. So overall, what is the solving? If you take 1 by 20 outside, if you take 1 by 20 outside, then minus 1.2 plus 1 is again minus 0.2. So which is 1 by 5. 1 by 5 is 100. So what is the thing we are getting is minus 100 will be coming as answer. Okay, so assuming all the thin, so this is it. This is the maximum they can ask, combination of lenses, nothing more we can expect. Okay, so simple formulas, how to find focal length, how to find combination, that's it. In lenses, maximum, and next is image formation. There's nothing more is there. So I hope you are understanding that ray optics is easy. Ray optics is easy. Once two things you are required. You should know the formulae, and formulae are not enough. That is a concept required. That is understanding what they are asking, what you have to substitute. Then 2-3 minutes you can solve it. So next we have is again biconvex lens. We having biconvex lens having the radius of curvature r is equal to 20 centimeters each, and the refractive index of the material is 1.5. Direct question. See, power directly they are asking. So how do first we can find focal length? 1 by f is equal to mu minus 1 into 1 by r1, and since it is biconvex, minus or minus becomes plus 1 by r2, then 1 by 2, and 1 by 20 and 1 by 20 becomes 1 by 10. So what is the focal length is coming out to be 20 centimeters. We got focal length, but we want power. Power is equal to, if you're using focal length in centimeters, so 100 by f, so 100 by 20. What is it? It is 5 diopter it is coming out. Okay, so this is what will be the focal, that is the power we are asking, so that is 5 diopter it is coming out. Okay, next, so regarding the lenses only you are seeing the most of the questions are, that is why it becomes very important. Let us see how this question they have framed. An object is mounted on a wall. Okay, there is an object which is on the wall. This is on the wall. Fine. An image is of equal size to be obtained on the parallel wall. Image should be also be same. So when object and image will be same. So again, you know, there is only one condition. When if this is kept at 2f, if this is also at 2f distance, then only it is possible. There is only one case it is possible. and that's what a convex lens is spaced between the walls. The lens is kept at a distance of x. Lens is kept at a distance of x in front of the second wall. If this is x, but what is x should be? X should be is equal to 2f. Now what is asking? What is f should be is equal to? X by 2. Again, that's what concepts, if you know, then the answer is direct. Nothing to think here. Okay, so this is what we are seeing, ray optics, and here lens. Again, the questions, lenses they are asking recently. Previously, little bit earlier, they were asking mirrors more. Now the trend is on the lens. Okay, so let us see this question. What is the thing we are having? An object is placed at a distance of 60 centimeters. Okay, object is placed at a distance of 60. Here it is there. And focal length is 30. If focal length is 30, it is a special case, right? It is 2f. If it is 2f, where the image should be formed? At 2f. So it wants to go beyond, but it is not allowing. So what will happen? The mirror will reflect back. It wants to go 20 centimeters this side, but mirror will make sure that it forms image 20 centimeters forward. Okay, then they're asking what is the final image formed. Okay, so how many things are happening? First object, light passes through lens, now lens to mirror, and again light, lens to mirror, mirror to lens will be coming. The last step is mirror to lens, we have to see, and then the final image is formed. So final image, so we got this point is at a distance of how much? So it was 20 centimeters now. Now this is the image location. If this is image location, so light is coming from this side. So final through the lens we are studying now. U is equal to minus 20. F is equal to 30 centimeters. We want to know 1 by V, minus or minus become plus, 1 by 20 is equal to 1 by 30. So 1 by V is equal to what will be coming? 1 by 30 minus 1 by 20. So 1 by 30 minus 1 by 20. So 20, 30 minus 600. So V is equal to 60. So we'll be getting what? From here the image will be formed again at 60 centimeters this side. So once again let us calculate it here. What will be coming out? 1 by V is equal to, so minus 10 by 600. Okay, so right. So what is the answer we should be getting? So we want to calculate the distance from mirror. We want to calculate the distance, and also they are asking to find whether it is real or virtual. So what will be coming out here? We got focal length. Just we'll solve it in the next page as well. So first we started from 60, we gone to 60, but it is making it to reflect back, and this is 20. So from here total 40 is there, 20 gone, so remaining is 20. So if U is equal to 20, minus 20 we have taken here, and F is given. So when it comes here, so it is coming minus 1 by 20. So overall V is equal to 60, it is coming out. If V is equal to 60, then what we can do, so we want to measure the final image, two things. Okay, just let us do the steps once. So this was a lens and this was a mirror. So first it was 60 centimeters, and here this was object, so where the image will be formed. The image was trying to form, because F is equal to 30. When F is equal to 30 centimeters, I'm just showing you once again. So this was trying to go here. If this was trying to go here at 40 centimeters only, it was mirror is stopping, so it wants to form behind the mirror. This is a virtual image. Then for virtual, it is going to reflect. It is going to reflect, it is going to come here. So this is 20 centimeters. Then this is going to be 20 centimeters. We got it. Okay, so now we are getting, finally V is coming out to be minus 60. If V is coming to be minus 60, then, so we got, just now we solved, when if the object is placed between P and, that is O and F, then if V is equal to finally minus 60, that means it is this side. If it is this side, then first of all it is virtual image. Final image is what? Virtual image it is, and we have to look for the distance from here minus 60 if you are going. So from the mirror it is going to be how much? From mirror it would be 20 centimeters will be coming out. Okay, so we step by step we are following. First the lens is forming, then mirror is forming, then again lens is forming. Okay, these things are happening here. Okay, so this is a little bit again imaginative based question. Okay, now coming back to TAR. So TAR, what is the concept here? We are sending white light, but if green light is undergoing, so we know what. So refractive index depends upon that Cauchy's relation is b by lambda square. If for red, it is only comparison between red and blue or red and violet. If you see just one small concept here, here lambda is more, so mu is less. If mu is less, sin theta c will be more. If theta critical angle is more, if critical angle is more, then there is a less chance of undergoing TAR. So red has less chance of undergoing TAR, less chance of undergoing TAR. If and blue has the violet side has more chance. That means, and if you see the spectrum, web G, yeah, if this is grazing, if green color is grazing, then these three will undergo TAR and these three we don't undergo, they cannot undergo TAR, so they will leave. So what is the answer will be? They are asking which will be coming out, which are coming out are the ones which are not undergoing TAR. So what should be answer? Yellow, orange and red. So all this simple technique is red. It cannot stay inside. That means it has less chance of undergoing TAR. So there is a comparison is going on. You should see that. So in the colors, so the lower wavelengths they have better chance. Higher wavelengths has less chance. That is what will be the standard case. Now coming to the topic prisms. In prisms, so what is the thing we are doing here? Again, I told you the formulas. Which prism is this? Thin prism. In thin prism, so only two formulas will be there. One is the angle of deviation and other one is, okay, that simple directly they are asking here. So for thin prism, a horizontal ray is incident on a right angle prism whose angle of prism is 6 degrees. If the refractive index of the material is 1.5 and angle of emergence will be how much? So we have a right angle prism, that's what we are seeing, and the angle of emergence they are asking. So you can see that this ray is going undeviated because it is, so basically this is a deviation. How to find deviation for the thin prism? Thin prism, delta is equal to what you can write, mu minus 1 into A. So mu 1.5 minus into A. So that is what? 3 degrees. So deviation is 3 degrees. But what they are asking? So they are asking to find emergence. So if you use delta is equal to 1 plus C minus A, this is a prism formula. So deviation is 3, I is normal incidence 0 and E is what you are looking for and A is 6 degrees. So what will be coming out? E is equal to, if we send 6 this side becomes 9 degrees. So what is angle of emergence? 9 degrees it is. Okay. So that's it. We have the formulas. Again, you can see that all the questions we are doing just based on the first two slides where I gave you the summary of the formulas of the ray optics. Again, nothing much is there. Ray optics is few formulas and concepts. A light ray enters, again it is a prism, right angle prism. A is given as 90 degrees, fine. And angle of incidence is given as 30 degrees, okay, fine. And light travels to prism parallel to its base, it is traveling parallel to its base, okay. And it emerges along the face AC. It is E is given as 90 degrees. Then they are asking to find refractive index. We have we have I, we have E, we have A value, we want to find refractive index. Okay, so refractive index, how do you find here? So this is a critical angle, then only it is going to happen. And this angle is R. So what is the thing we can use here to find? This is okay. So we have one unknown, we require, okay, we have two unknowns. We need to find, okay, just one by one, step by step we can go. First, Snell's law, because 2 times refraction First refraction here, second refraction here. First refraction, we can write sine 30 is equal to mu sine r1. Okay, fine. Then second refraction, directly what we can say, it is a critical angle. So directly r1 plus r2, I'll write it as theta c is equal to a, which is 90 degrees. So in the place of r1, I can write what? 90 minus theta c we can write, isn't it? This is from second, that is a prism formula. Then so we can substitute here. So sine 30, that is 1 by 2 is equal to mu into sine 90 minus theta c becomes cos theta c. Okay, there comes now calculations will start to begin. 1 by 2 is equal to mu. What is sine theta c? Can be written as 1 minus sine square theta c, which is 1 by mu square will be coming out. Now if you square it on both sides, 1 by 4 is equal to mu square into 1 minus 1 by mu square it is. And what will be coming out? Okay, just we have to multiply. 1 by 4 is equal to mu square minus 1. If you send it 5 by 4, if you put it, root of 5 by 4 is root 5 by 2. So answer will be root 5 by 2 will be coming out. Again, if you are applying the basic concepts, you can get the question solved. You should not think much here. If you start thinking, then what is happening, why it is happening? So simple angles are involved regarding to refraction, and they are asking to find refractive index. We can always take the help of Snell's law. Any question can be solved. Angles, refraction, refractive index, only one thing, Snell's law, apply it, you will be getting the answer. Okay, and now once again, okay, critical angle finding. How to find critical angle? Sin theta c is equal to mu r by mu d. So lesser speed, so if you want to find refractive index here from the speed, we can go with the lesser speed, that is 1.5 into 10 power 8 by 2 into 10 power 8. So this we can got cancel, it is coming out to be 3 by 4, that is 0.75. So sin theta c, so theta is equal to sin inverse of 0.75. Again, almost direct question, but instead of giving the refractive index, they gave the speeds. Still we can use a relation. Mu is inverse proportional to speed, we can do this. Again, see, prism is also becoming a favorite topic for NTA. So we have angle of incidence. This is where I is equal to 0, and refractive index is given, so it is going to go like this, and it is incident. So if you draw the normal, here. So since this is 30 degrees, this is 90, this is 60. If this is 60, this is 30, and we want to find what angle of emergence. Okay, it is going to come out. If it is going to come out in this manner, what is E we want to find? So again, angles are involved, refractive index is involved. Snell's law. Refractive mu1 is root 3 into sine 30. Okay, so 30, 60, 30, 60 and 30, yes, and this is entering into air and sin E. So what it is coming out? Root 3 by 2 is equal to sin E, it is coming out. That means what is E is equal to 60 degrees. So it is taking 2 steps, and again these questions, yes, you should need to work on the application, basic application. Prism standard questions, do them once again without seeing once from your side also, so that you will be very clear with this kind of questions. Now we have application based convex lens. Convex lens is given 20 centimeters, fine, and concave lens, focal length is given, concave lens, focal length is given 5 centimeters, fine, and are kept along the same axis. Okay, and the distance is given d. The parallel beam of light is incident on A. So a parallel beam of light is incident on A. This is the lens A, and leaves as a parallel beam. It is coming and leaving as a parallel beam. That means, so what is happening is effective focal length is 0, or we should say effective power is 0. So effective focal length is infinity. That's what I should say here. So when we have discussed one formula, right? When the lenses are in contact, When in contact, formula is there. That is 1 by F effective is equal to 1 by F1 plus 1 by F2. This is what we have to use. But here they are not in contact. And light is going where? To infinity. So effective focal length formula, when they are separated, we have another formula. Now I will tell you. When separated by some distance, what is the formula? So 1 by F effective is equal to 1 by F1 plus 1 by F2 minus D by F1 F2 it is. So that's it. Now it is going to infinity. So this is 1 by infinity. I can write it is equal to 1 by convex lens positive and concave lens negative. So minus or minus become plus D by again 20 into 5. So if you start solving here 4 if you multiply minus 3 by that plus becomes plus. So 3 by 20 is equal to D by 20 into 5. So 20 got cancelled. What is the distance they have to maintain? 15 centimeters we have to maintain. If you maintain the distance between the two lenses 15 centimeters, so you will be getting that the ray which is coming, so the ray which is trying to fall, and again it will be diverge and it will be going to, so this ray wants to converge here, but this lens will make sure that it diverges and goes to infinity. So two formulas you should remember. How to find effective focal length only it is valid for. Don't use wherever you want. If you want to find effective focal length when they are in contact, there is no D here. If there is separation, put D by F1 F2 will be coming as a formula here. Okay, this is one question where based on effective focal length we can say. Next, a ray is incident at an angle of incidence. Again, small prism, thin prism, it emerges normally. Again, it is a direct kind of question. Let us see different model questions. Yes, TAR, similar diagonal question. Okay, let us see this rainbow. Rainbow, they asked 1 or 2 times here. They are asking to find wrong answer. So when the rainbow is formed, so do you see rainbow in the afternoons? Only rainbows will be either in the morning or in the evening when the sun is at lower angles. That is, the light should be coming at an angle of 40-45 degrees around. When the sun is in the evening, and when the rainbow is there, you will not be facing the sun. Sun will be behind you. So if this is somewhere moisture is there, the water droplets, the light will enter the droplet of water. It will undergo, if this is a droplet of water, light will undergo refraction, reflection, again it is going to be refraction. It is a double refraction including TAR. So then the light will be reaching, and you will be seeing splitting of light, and you will be seeing it as a rainbow. So for the rainbow to appear, the sun which is there, it should be behind you, not in front of you. That's why it is wrong answer will be coming out. And it involves, yes, dispersion, refraction and reflection of light will be there, and it undergoes internal reflection. And okay, for secondary rainbow, yes, 2 times will be happening, and the order of colors will be reversed for secondary rainbow will be coming out. Yes, because of 2 times reflection it will be changing. Now coming to the last topic of ray optics, that is telescope. They asked the questions on telescope. So telescope is simple case, so where the magnification for when the relaxed eye, for the relaxed eye, the magnification M is equal to, what is the formula? FO by FE. Direct question is asked here. You see, they gave objective focal length. Objective focal length is 140 centimeters, and eyepiece is 5 centimeters. So what is magnification? Magnifying power is coming out to be, this is 5, this is 28 times. So magnifying factor, the magnifying power is 28 times. It is again direct for the telescope. And for the relaxed eye, length of the telescope should be FO plus FE. This is one more relation we should remember. Okay, so again revise the formulas. There are 2 times the questions have been asked the same thing. So here also we have objective and eyepiece is given, focal lengths are given. How to find magnifying power? So magnifying power M is equal to, so now 20 convert into centimeters divided by 2, so it will be 1000 will be coming out. So magnification is 1000 is correct, and the distance between objective and eyepiece is, yes, if you add, so what is length is equal to FO plus FE, it will be coming out, this also correct. Image will be erect and diminished, no, astronomical telescope will form inverted image. It will not be formed image, it will be magnified image. And aperture of the eyepiece is smaller, yes. Objective length will be bigger and eyepiece will be smaller. This is how the telescope will looking like. The front one will be big, aperture will be big, behind one will be small. So what is the option which are correct? A, B, D are correct. So A, B, D are correct. Okay. So this is optics, ray optics, and now we'll have to do wave optics. Again, small topic, few questions, they'll be very much focused, and one question on an average you can expect one question, but last year they asked 2 questions. So again, what is the favorite topic here is YDSC. YDSC and as well as some formula based on diffraction formula, polarization. Only 3 topics. First, you complete the interference part, and you can also see the formulas. What are the formulas involved? So for YDSC, so it is all about interference. Interference, constructive interference, the condition delta x should be equal to n lambda. For destructive interference, delta x should be equal to 2n minus 1 into lambda by 2. So, and then there are other cases like in especially YDSC, when the screen is very far, when the distance is very large when compared to the distance between the slits. So if the light is going, so there is a path difference of what do you say, d sin theta, and if the this is theta, if this is y, so we write d sin theta is equal to delta x, and when d is very large, when d, then d can be sin theta can be replaced with this and delta x. If you want constructive, take n lambda. If you want destructive, take 2n minus 1 into lambda by 2, and you can see the results. And maximum the questions will be this, and they'll have some special cases of putting the slab here, and what is the number of fringes and fringe width. So those kind of, so all in the special case of interference is that all fringes are of equal width. All fringes are of equal width. And what is the formula for fringe width? Beta is equal to, okay, so lambda capital D by small d. And angular width, if you want to find what is angular width, the formula will be coming out. So theta is equal to beta by d, that is lambda by d. So on this, theoretical questions can be asked as well. Like, so if you immerse this setup in water, what happens to fringe width? So in that case, lambda will decrease, so fringe will decrease. And if you replace, so what is the purpose of interference? One more thing I should clearly mention, that the sources has to be coherent, and for YDSC setup we take monochromatic source. Why we have to take monochromatic source? Then only the pattern will be visible. Instead of monochromatic, if you take white light, what will happen? All the colors, one red color fringe width, blue color fringe width will be different, so overlapping will take place, so the things will not be very much clear. So what are things we are focusing here is, so just a few things, few formulas, and like, so when you go to diffraction, the results are little bit different. There we say aperture a sin theta is equal to n lambda. For minima it is will be coming out if you want to find minimas, and a sin theta is equal to 2n minus 1 into lambda by 2 will be for maximas. Here the results are opposite. If you see, the results will be opposite. This is maximas and this is secondary. This is secondary, minimas and maximas. And in the case of polarization, there are only 2 formulas are there. One is Malus law. So it gives us intensity through polarizer. I is equal to, what will happen? What is the output? Is equal to input intensity into cos square theta, where theta is angle, we'll be seeing that, and Brewster's angle. What is the formula for Brewster's angle? So again, it is related to what is the angle of incidence for the light should be, the reflected light to be completely polarized. So again, so tan I is equal to mu. So for angular polarization we'll be saying. Okay, we will just, questions are directly asked. This is it. If you know understood these things properly, then wave optics is done. Let us see few questions here. So interference pattern can be observed due to superposition of which waves? Interference to happen, they're asking which waves to be superimposed. One thing just now I said, that the waves should be coherent, meaning what? They should have same frequency. here frequency different. Here frequency, these two are same. So that means A and C, they could be undergoing interference here. Again, simple direct question. See, now the favorite topic in wave optics is YDSC is here. So D is given, the distance between the slits is given as 1.5 mm, and the screen capital D is given as 1 meter, and wavelength is also given 600 to 10 power minus 9 meters. Then fringe separation, that is what is the distance, is nothing but fringe width. So again the formula is lambda capital D by small d. You can just substitute it, you will be getting the answer. Okay, just I'll give you a quick review of the questions here. If monochromatic source is used, okay, is replaced with white light, what will happen? Then the fringes will not be clear, interference pattern will not be visible. So what will happen? Only the central part will be clear, remaining all will not be clear. So central bright fringe will be clear and remaining will be colored fringe will be coming out. Okay, so this is what will be happening. And so in the case of same YDSCC, the questions will be repeating. If the screen is moved away, angular separation remains constant. Yes. So if you see the formula, angle, does it depend on capital D here? No, it only depends on lambda and small d. You may change capital D, it's not going to be affected. So statement 1 is true. If monochromatic source is replaced with another monochromatic source of larger wavelength, angular separation decreases. No, it is not correct, because theta is equal to lambda by d. If wavelength increases, theta should increase. They are saying decreasing. So statement 1 is true, statement 1 is 2 is false. So option B will be coming out. Okay, formula based theoretical questions will be asked. Again, the screen is moved away, what will happen? That is what just now we saw the same question. And again, number of fringes they are asking. How do you find number of fringes on the screen? So in the YDSC, student observes, so sine theta, that is a d sine theta is equal to n lambda. D constant, then when we go for maxima, so sine theta has a particular maxima. If these two are constant, n into lambda should be constant only or not. So that means we can write simple n1 lambda 1 is equal to n2 lambda 2. So first 8 fringes for 600 nanometers wavelength. Now for wavelength to be 400, what is n2 will be? So we can write two zeros got cancelled once, twice. So n2 will be coming to be how many maximum? 12 will be coming out. You will be seeing 12 will be coming on the screen. So again, this is one special case it is. So again, we were speaking, this is the last topic, that is a polarization. So where we have, this is when the light is, when the vibration is in all direction, this is unpolarized light. When it is passing through polarizer, its intensity becomes what? Half will be gone. Now you see the transmission axis is making 60 degrees. What will happen? It becomes I naught by 2 cos square 60. Okay, and then we have angle is making, so again 45 degrees. So that is what is given. First polarized, then through B polarized 60 degrees, and finally through another polarized 45 degrees. So relative to B. So with respect to B, it is making 45 degrees. So in this manner, so finally what is the intensity will be? So first time it gone, became I naught by 2. Second time it became I naught by 2 cos square 60. This becomes what? 1 by 2 whole square into 1 by 4. It became I naught by 8. Then it is making 45 degrees. Once again, Malus law if you apply. So I naught by 8 into cos square 45. What is cos square? Cos 45. 1 by root 2 whole square. So it will be coming up. Okay, 1 second. Yes, fine. This is I naught by 8 into 1 by 2. It becomes I naught by 16. So what is the final intensity will be coming out to be? I naught by 16 will be coming out. Okay. So this is how the questions we are seeing. Again, intensity of final thing. The same formula you can apply the things. And lastly, Brewster's angle will be seeing, and we'll be closing it for today. An unpolarized light strikes a glass surface at the Brewster's angle. What happens? If this is a surface, if light falls at a Brewster's angle, the light which is reflected, it is completely polarized. This is a key point. It is a completely polarized. That is, reflected light is completely polarized, and whereas refracted light is partially polarized. So this is a concept here. Nothing much they'll be asking. That's what. So refracted light is not complete. Reflected light is complete. So both will be complete. No. reflected is completely polarized, refracted is partially polarized. So answer will be D will be coming out. Okay, so this is it. This is what the questions, and this is what will be ending for the day. So next topic will be the dual nature of matter. Again, very important topic. At least 1 or 2 questions can be asked here. 2 important topics here: photoelectric emission and de Broglie waves. Okay, so do revise.